Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocket Man, and we talk about science, space, and economy. Hey, Ben, how are you?
Hi, Simon. How's it going? Hi, fellow Econauts. Simon, what's the topic today?
We are talking about life, and my first question is, hey, what's life?
Well, it sounds like a very simple question, but I let me start with a counter question. When does life start? And I think we could have a very long
Oh, yeah.
discussion about that.
Oh, yeah.
You're right. Like, is it when
Also a very
speaking of
sensitive topic.
fertility? So let's not go there.
Yeah, no.
But let me tell you one thing though. So from the biological point of view, there are a number of things which define a living organism. That is, for example, organization. It will, it eats. It has a metabolism. It can procreate, and so on. There's a number of things which define life. And interestingly, even from this definition, some things here on Earth or some individuals on Earth, which we would both clearly agree are alive, would actually not fulfill this definition. And you may ask what this might be. And this is a very tiny insect. It's an ant. If you take a single ant out of a colony, a single worker ant, that ant cannot procreate. So it would not fulfill into this definition. Another example is a virus. A virus is not living because it does not have its own metabolism, and therefore, per definition, it's not alive in this sense. And yeah, but I think why this is important is obviously when we talk about space, everybody wants to find life in the universe. Well, maybe not everybody, but I think it's very big out there. It's a very big topic exploring our universe.
Especially these days where there are rumors that there are actually life on Earth that is actually not from Earth, right?
Yeah, yeah. Maybe I mean there's some theories and some hypotheses out there that even our evolution has started with being contaminated by an asteroid, which landed on a very young Earth and started all the process led to what we are now. So who knows? No, we can't really go back in time and see what happened.
Coming back to the ants for a second, I think if we look at the entire colony and a single ant, it's more like an arm or finger in that case. Is that correct? So it's
Well,
kind of
still,
alive because it's part of a larger organism.
yeah. The funny thing is, and you're doing exactly what everybody would do now. You try. There's a common sense in yourself which clearly tells you that even a single ant is alive, and therefore you're looking now to expand the definition. But in science, you usually find the one definition, or the aspiration is there to find one definition which clearly defines a certain status of a thing. But we already, with the simplest thing in biology, the word in itself means the science of life, the theories of life, and still we can't really define even what is life. And if you expand that, like, where do you stop there? I'm sure, I'm not a biologist, but I'm sure that you can find a huge number of exception to this definition. And therefore, where do you stop?
My
And where do you
my
start?
favorite episode, or one of my favorite episodes from Star Trek, is the one where Data is on trial, where he's like, is he alive or not? And one of the questions that is asked is, what about fire? Because it is reproducing, it is growing, and it's also dying. So in theory, it's life. It's
Yeah,
alive, right? If
yeah,
you
you
really
can.
think
So
about it.
yeah, you're right. And even if you build a robot, you could build a robot which technically could then reproduce and like all fulfill all these definitions. But if it doesn't have its own self-awareness, would you then still say it's alive or not? Like, can you still turn it off or on? I think there's many pathways we can really explore, which make this a very interesting topic. And but maybe to come back to where I'm getting at and why I think it's an interesting topic for space science and economy is obviously finding life in the universe is one of the main missions of most space agencies, especially NASA. And in the recent years, the definition of the word life has even been changed. And I think maybe some people have already noticed that we write life with a Y. And why is that? Because NASA, we tend to look for things which are similar to life on Earth. But who says that we don't have other forms of life or other things which are alive but would not fulfill this definition? And as I already said, obviously there are some examples even on our planet which are clearly not fulfilling this definition. And therefore, why should we, if we look for life in the universe, limit ourselves to find life as we know it? So, and that's why there are a number of papers out there to find life as we don't know it, so to say, right? And I think Star Trek is a really good example because there's many different life forms which do not fulfill these criteria. There's energy forms, gas clouds, which have an organized structure and self-awareness, and data itself. You could say it's sort of a life form because it, clearly he doesn't want to die, and has emotions in a sense.
Yes, and not well. At some point he has, but I also think that Star Trek does a very good job asking that question, not only in form of data, but also with the Doctor in Voyager. And there are many, many episodes where we start questioning if something is alive or not, right? There is this episode with the moon, where they try to terraform a moon and then realize that the soil it's alive, more or less, very teeny tiny organism. And it's I think Star Trek does a very good job to question something without really giving an definite answer, right? Because that's something that often is the case. We not have a definite answer to some
because
of the
we can't find the definition. That's my point. It's very hard to find the definition. You mentioned the Doctor. Obviously, I think you're talking about the Doctor in Voyager.
Yeah, the holographic Doctor.
Even in Star Trek, there's Dr. Moriarty in that hologram.
Yes.
He's becoming self-aware. And also, is that alive now? Can you turn it off? In that episode, they decide he is alive, so they won't kill him. They preserve him on a little data stick and give him a universe to explore, sort of to do something in its own world, more or less. But they won't.
We're going into the Matrix right now. Are we even alive? Are we even alive? Right? Is that
also,
real?
I mention emotions and hormones and stuff like that. Is that a necessity for life? I mean, clearly most cells don't have emotions, and still clearly they are alive. And going to a sentient being, which is, I think most people think when they are thinking of life forms, sentient beings, I don't think they have to have those criteria. And AI is more and more going in this direction. We are still far from sentient beings still, obviously, but there are tests which have been defined for artificial intelligence to see if they are becoming alive, and some AIs can already fulfill those test criteria. Although these test criteria are questioned because they are not comprehensive enough. But you know where I'm getting at, right? Again, we try to define a boundary, and we find already examples to sort of overstep that boundary, and still everybody can clearly see, okay, we're still not there, but then the definition seems to be wrong. Right. And I think that's a very interesting topic.
It is indeed. So then that is leading to the next question: how do we look for life? If we have a hard time defining life, how can we look for life?
So there's a number of criteria which are investigated, and I can't tell them by heart now, but obviously we still look for life as we know it, because that is what we know, right? We know certain cell structures and so on. So when NASA is sending a probe on Mars, they will collect things. They are then stored in the moment for collection. So we do still have to bring them back. And then once we have them here, we can investigate them, with spectroscopy. We can do microscopy and so on. We can, magnify and see if there are cell structures apparent or fossils, so from older life. But here's another interesting fact about finding life. So as I stated, we send probes to see, if the conditions of life would be fulfilled, such as having a similar atmosphere as on Earth, which might not be necessary, but for life as we know it is necessary. But the interesting part I wanted to point at is NASA won't land where they would expect life. Why is that? Because the very act of landing with a lander might destroy that evidence of life. So we have to land far away from where we actually expect, where we would be able to find life, which puts us far away from that spot. There's a bit of a controversy.
Yeah, we
You know
also
what I
don't
mean,
want
right?
to break the prime directive, right?
Well, yeah, that's another story. But you know what I'm getting at, right?
Yeah,
Let's say, to make this more clear. So maybe I'm jumping ahead with my conclusions here. But let's say we have a planet such as Mars, and we think that life only exists or existed in the past, so that we could detect it around the equator of Mars. So obviously, now the common sense would dictate that we land at the equator, so that we can send a probe there, because anything away from the equator is too far to reach with a rover. So, but because we don't want to destroy it, we land at the pole. So we land at the pole, and we can't even reach
so just
the
around the neighborhood, actually, right?
yeah. Well, but you get what
I'm
I'm
getting
getting at,
that.
right?
You
Yeah,
can, if you would land exactly. I mean, it's like, if you squash the ants, then you can't find the ants anymore,
yeah,
right? It's
yeah,
like the same
exactly.
thing. You
Yeah,
don't know what to expect. You cannot expect that there is a dinosaur on the planet that you can actually see from orbit.
yeah,
It is
exactly. Yeah.
possible that the organism is teeny tiny, and if and the last time I checked, if you land on a planet, there's a little bit of heat coming out of the landing part, right? To actually, teeny tiny bit,
Titsy tiny,
teeny
yeah.
tiny bit.
Yeah.
So yeah, I get that. If you expect life on a planet, you have to be very careful. Which actually brings me to another question. So how can you look for life? So you're sending a probe, but even the probe can destroy life. So how do you do that?
That's the dilemma. That's the dilemma NASA has. That's why they can't land where they actually expect life. They land far away from it, right? That's exactly the problem they have. But at the same time, and I guess that leads us to another discrepancy, let's say. Obviously, the life can have different evolutionary steps. So we
Yes.
can look for microorganisms. For those, we have to get the probe, or we have to have like a sample, or we have to have the apparatus there which can investigate that sample. But then you have to send everything you can think of, like spectroscomer, microscope, and so on. You have to have everything there, and that gets very complex to build, like in a machine, so that you can do everything at once. So it's easier if you have a sample here and you have different scientists then being able to look at it and having different approaches. If you have large life forms, such as plant-based life, for example, and you could see a forest from the atmosphere, you still have to be close. We can't see maybe within our solar system, but obviously our solar system is unlikely to bear other life. There's other solar systems, but we can't even see the planets from other solar systems. The only reason why we know that other solar systems have, or star systems have planets, is by the blinking of them. So the blinking actually tells us how often planets revolve around that star, which is why we know that there's a planet around, or planets around that star. But we don't even know how that planet looks like. We don't know what atmosphere that planet has. For that, we would have to send something to that solar system, to that other star system in the first place. Otherwise, we can't see the forest. So the very next thing would be sending out electromagnetic waves, which we have done. SETI is a good example. The search for extraterrestrial intelligence, but that requires that other life form, that other species, or that extraterrestrial life is already at a point in their evolution that they actually have radio transmitted signals.
Right.
So there's a huge spectrum. So finding life is actually turns out to be very, very hard.
Yeah.
In the universe, and yet the statistics dictate there's so many suitable planets in the whole universe that the likelihood that there's other life is actually very high, or the other way around, the likelihood that we don't find other life is very low.
Right. We just don't have the technology to actually explore that, at least not at the moment, right? I mean, it would take us a lifetime just to get to the closest system, right?
In the moment, it's impossible. We don't have any machine in the moment which would bring us within a lifetime
I'm just
to another
I'm
star
just
system.
saying, like in theory, if we would send a rocket that we have access to right now, it would take like forever to send that to another system, right? So we would need many generations, a generation ship, so to speak, to actually reach the other system, right? And then it's not even guaranteed that they will find a planet that is like suitable for us.
And if they send any signals back to us, so the next star system, what is it? Is it Betelgeuse? Or is it, which one is it? I don't know anymore.
Alpha Centauri?
Alpha Centauri. And I think that's 3 to 4 billion, 3 to 4 light years away from
4
us.
light years, yeah. I think it's 4 light years.
So that, which means any signal sent from them would take 4 years to reach us. So if they say something, you can imagine the conversation is very like, hello.
Very one-sided.
Hi. 4 years later, have you found any life? 4 years later, nothing anymore. They died. It's like, shit.
I mean, when I have to edit our show, I mean, we have sometimes little hiccups. And we are just, Australia and Canada. It's not that far apart. Just Alpha Centauri and Earth. Hi Earth, it's me. And you have to wait 4 years for an answer.
Imagine the Econauts send it from Alpha Centauri and the solar system. And then, hi Econauts, hi Simon. It's like 4 years later. What is the topic today? Oh, the topic 4 years ago was.
The topic 4 years ago was, yeah. We need to have a black hole that is like, or some sort of wormhole that is actually allowing us to do that quicker.
Yeah.
All right. So let's close this episode with a question that we started with. It's like, what is life?
Yeah, what is life?